Hello everyone, welcome back to my channel. I'm back with another video. Today I'm gonna talk about Wumpus World. Let us see the contents: introduction, basic concepts, rules and mechanism of the game, strategies and techniques for playing, knowledge representation, interface and reasoning, search algorithms for navigating the world, heuristic approach for solving Wumpus World, conclusion and key takeaways. Let us see Introduction to Wumpus World. Wumpus World is a classic environment in artificial intelligence where agents perform actions to explore a dungeon and hunt down a mythical beast known as a Wumpus. It's a captivating concept in the principles of AI that provides a rich context for learning various AI strategies and techniques. Let us talk about basic concepts of Wumpus World. Sensory information. Agents in Wumpus World only receive imperfect logical information through a sense of perception. Movement and direction. The agent can move and change direction to explore the cave and must carefully plan its movements. Risk and reward. The game involves managing risks and rewards when making decisions. Let us talk about rules and mechanics of the game. Perceptual information. The agent receives sensory information such as stench from the wumpus and breeze from pits. Agent movements. The agent moves through the cave and shoots, grabbing gold, avoiding pits, and dodging the wumpus. End game conditions. The game ends with the agent either wins by grabbing gold and leaving the cave or loses by running into the wumpus or falling into a pit. Now let us see strategies and techniques for playing Wumpus World. Wumpus World is a popular artificial intelligence game where the player acts as an agent navigating through a cave filled with hazards such as bottomless pits and a dangerous creature called the Wumpus. The objective of the game is to find the gold and exit the cave safely without being killed by the Wumpus or falling into a pit. The Wumpus world environment is represented as a two-dimensional grid where each cell represents a room in the cave. The agent can move from one cell to another, shoot arrows to kill the Wumpus, and collect the gold if found. The agent can perceive the environment through a set of sensors that provide information about the surrounding cells. The agent can perceive if there is a breeze in adjacent cell, indicating the presence of a pit, or a smell indicating the presence of the wumpus. The agent also has limited number of arrows that can be used to kill the wumpus. Successful navigation through the cave requires careful planning, risk management, and goal-oriented actions. The agent needs to explore the cave while avoiding hazards and collecting information to make informed decisions about its next move. The agent also needs to plan its actions based on the ultimate goal of finding the gold and exiting the cave safely. Strategies and techniques for playing Wumpus World. Risk management. Strategies for optimizing movement to minimize the risk associated with unknown elements in the cave. Assesses the risk of each move and prioritize safety over speed. It's better to take a slightly longer route if it reduces the chance of encountering hazards. Implement a backup plan in case a risky move doesn't go as planned. Explore safely. Move casually to explore the cave without falling into pits or encountering the wumpus. Use the information gathered from percepts to make informed decisions about your next move. Remember to mark visited and safe cells to avoid revisiting dangerous areas. Goal oriented actions. Techniques for setting and achieving objectives while navigating the cave. Identify the ultimate goal and break it down into smaller sub goals for easier navigation. Adapt your goals based on the information obtained during exploration. Approaches to constructing decision trees to guide the agent's actions effectively. Consider the possible outcome and their probabilities when constructing decision trees. Regular update and refine the decision to based on new information. Let us talk about knowledge representation in Wumpus world. Logical interference. Representing and using logical reductions to reason about the cave's hazards and opportunities. Belief networks. Modeling the agent's beliefs and uncertainty to make informed decisions. Probabilistic reasoning. Utilizing probability to evaluate and update the agent's beliefs based on incoming sensory data. Let us talk about inference and reasoning in Wumpus world. Observation. Agent must observe sensory cues and deduce information about the cave. Logical deduction. Utilizing logical rules and deductive reasoning to draw conclusions about the cave state. Probabilistic interference. Utilizing probability theory to make decisions uncertain or incomplete information. Now let us see search algorithms for navigating the world. Breadth first search. An algorithm exploring the cave layer by layer using a queue data structure. Depth first search. An algorithm navigating as far as possible along a branch using a stack data structure. A star search. A best first search algorithm combining elements of uniform cost and greedy searches. Let us talk about heuristic approaches for solving Wumpus world. First is Manhattan distance. Calculate the Manhattan distance between the current cell and the goal cell. This heuristic estimates the number of moves required to reach the goal based on the distance in the horizontal and vertical directions. Second is heuristic evaluation of states. Evaluate the current state of the Wumpus world environment using a heuristic function. This function assigns a numerical value of each state, indicating its desirability or potential for reaching the goal state. Third one is weighted tile proximity. Assign weights to each tile in the Wumpus world environment based on its proximity to the goal cell. The weight reflects the desirability of each tile, with higher weights indicating a higher likelihood of leading out to the goal. Now let us conclusion and key takeaways. Complexity. The complex interplay of risk and uncertainty in Wumpus world teaches valuable AI concepts. Strategy. Developing effective strategies highlights the AI agents' smart decisions making under adversity. Learning. Learning from wins and losses conveys the challenges and richness of real world decision making. Thank you.